In the preceding two videos, we presented limit definitions that are useful for describing the behavior of a function as we approach a particular value of x. Some functions display interesting behavior not just at individual values of x, but as x becomes arbitrarily positive or negative. One tool we can use to investigate such behavior is the definition of limits at infinity. In this video, we present this definition. The notation read, the limit as x goes to infinity of f on x equals L roughly means that as x becomes arbitrarily large, f on x becomes arbitrarily close to L. This symbolic description translates into unpacked English as follows. For all positive epsilon, there exists a positive s such that insisting that x exceed s implies that f on x is between epsilon above and below L. To illustrate this concept more clearly, we sketch a function plot that flattens out for large values of x. We sketch a golden vertical interval between L plus epsilon and L minus epsilon. We can identify a positive s to serve as a fence post for an interval continuing forever to the right. Within this blue interval, the yellow plot of f on x versus x is vertically confined to the golden band. After decreasing the thickness of the golden band, which corresponds to decreasing the value of epsilon, we continue to be able to identify a positive s to define a blue-shaded interval within which the yellow function plot is still vertically confined to the golden band. This new value of s is farther to the right than the value of s from the previous slide. Even after yet again decreasing the thickness of the golden band, that is to say, even after decreasing epsilon once again, we can still identify a positive s to serve as a fence post for a blue-shaded interval within which the yellow function plot is still vertically confined to the golden band. Consider the possibility that the process we have illustrated in these last couple of slides can be continued by investigating finite values of epsilon that become small without restriction. Consider the possibility that, no matter what epsilon we investigate, there always exists a suitable finite s to serve as a fence post for a blue-shaded interval within which the yellow function plot is ensured to remain vertically confined to the golden band. If these possibilities are satisfied, then the limit as x approaches infinity of f on x equals L. In this slide deck, we explored the idea of the limit of a function approaching a finite height as x approached a finite value. We extended this notion so as to be able to describe functions increasing in height without bound, or alternatively, functions approaching a finite height when x increases without bound. In the next video, we define infinite limits at infinity.